Now I'm going to show you how to do orbital filling diagrams. And it's actually not that much different from what we were doing before. We have done orbital filling. If you remember, orbital filling diagrams are what I told you is that word orbital, right, is often used interchangeably with orientations. So what we need to remember is how many orientations are we looking at. Now this is the last problem that we did in that last video, so I'm just going to go ahead and use this because it presents us with a nice little quandary. So always, when you're doing orbital filling diagrams, please always use the shortcut method. Do not try and do this with the full length one. I mean, this neodymium one here would have 9 other terms in it, and it's that's just a lot of orbital filling to do. So what we're going to do here is we're going to use this. And by the way, you're going to notice the first thing in orbital filling, the first thing you have to do is you have to do the electron configuration, right? And I recommend always using the shortcut whenever you do orbital filling because it makes life so much easier. We can cut just like this, just like up here, we're going to cut 54 electrons out of here. That's 54 arrows I don't have to draw on this orbital filling. I appreciate that very much. And next up, we're going to do 6s. And so we need to remind ourselves, based off the sublevel, you hopefully have this chart already written down, S, P, D, F, how many orientations are in each sublevel, right? So I have to remind myself, S has 1 orientation, P has 3 orientations, D has 5, and F has 7. Remember that pattern, right? Each one can fit 2 electrons, and that's why you get a max electron. Some of you may have the max electron chart over here as well. Max of 2 in S, 6 in P, 10 in D, and 14 in F. But anyways, what we're going to do is we're going to draw 1 line above the S because the S only has 1 orientation, right? It's a sphere, only 1 orientation, so we draw 1 line. And we put 2 electrons in that. In fact, we have 2 electrons, so we're going to put 2 electrons into that. And the way we do that, we don't draw 2. Remember, we draw arrows. We put 1 spinning this way, and we put 1 spinning this way. Check. Next up, we got 4F. I'm going to give it a lot of space because I know I need 7 lines for that. Oh my goodness. F has 7 orientations, so 1, 2, 3. Oh, it's not quite center. 4, 5, 6, 7. Now you could write 4F under each of these, or you could try and center it. In fact, maybe, oh, I can move mine around. You gotta love that. Move mine to be centered in here. Now on the 4F, we don't have 14 electrons. We don't have the maximum. We instead only have 4 electrons. So remember, right, it was which principle? It's the Hund principle or the Hund rule, whichever way you want to remember it. Hund is the important part there. Hund. According to Hund, we have to put an up arrow before we put an up arrow in each line before we put any down arrows. So there are 4 electrons here. We're going to put 1, 2, 3, and 4. We ran out of electrons. These guys stay here. They're going to stay empty. We just leave them just like this. And this right here is what the electron configuration orbital filling notation or orbital filling diagram, depending on who you ask, is going to look like for this